Right. So, first of all the workshops up to whatever I had, I tried to market. Many of you missed citation or things like that. Check your email. If your workshop has a problem, I have sent you, uh, if your workshop has a problem, I have sent you an email. In that email, you will see a link. And if you click on the link, then you can actually get to the message that it carries. So essentially, um, I to kind of categorize all the mistakes that I see in workshops, I created a web page on our Git repository. So Git repository, there we go. I'm gonna bring it up. Yeah, so it's going to bring you to feedback page here. So one of these, as you see over here, problems that I see commonly happens, I add them. This was the one that you have most problem with, CT. So when you click on it, it brings you over here. It's going to say signature and citation of the yada yada is not accurate. Then you click over here. It shows you what you're supposed to do and citation policy, what it is. You have to apply that. Add your citation to the reflection of workshop 4 and send me a private message so I can check your citations there. Then I'm going to give you a mark. And this is a one-time offer on workshop 4. If you don't do your submission, it's zero and it's done. I'm not going to do anything else on that. And that's that. So anyways, check your workshops and you will see if check your emails, and if there is anything wrong, I will send you a message. Another thing is that many of you, your Outlook messages don't match your Outlook name doesn't match your Seneca name. I have no idea how this happens every semester, and many of you have nicknames, and your names don't match. So if I made a mistake on sending a message that doesn't relate to you, please let me know. All right, that's that, and let's begin. All right, so we created and the validated int class over there last time, and if you recall, something was wrong with it. Oh, it was the previous one that was wrong. Never mind. So anyway, and we did teach operator overloading through it. And I'm going to remove this add thingy that we don't need. So this is what we have done last time. And essentially, we mentioned that any operator that you create, essentially, if it's a binary operator, the left operand of the binary operator. So when we are actually having a binary operator, I'm gonna try and see if I can find one over here. So when we have something like this, if I have, and I'm gonna add a y over here, if I have y is equal to x plus v, something like this, when we have something like this, um, essentially, what is this thing? Then matches the operator. Oh, because we overloaded the operator equal, I think. Did we overload the operator equal? Mm, no, I don't see it. So in here, it actually says that this operator is not set. Operand types are int. So we created an operator equal. I'm trying to find it. Let me compile this because I just copied the things from the other side over here. I did not compile it. Let me just compile it, make sure everything is good before we continue. Compile. That's good. And this one doesn't compile. I'm surprised. I want to know why. X plus yx. Oh, we didn't do the plus yet. We didn't do the plus yet. I thought we did the plus. So we did an operator minus over here. I think this operator minus is actually operator plus that in class I was explaining about it, and no, it is actually correct. So I didn't do operator plus. Let me complete the operator plus. It's a good thing actually, now that we don't have it. So when we have something like this, like a plus between the two, we said that whenever you see something like this, immediately translate it into a member operator. So essentially say y is set to x plus v, and then put a dot over here, an operator, and then like this. So this is what you need to implement. So anything that you see. So if you see it is y equals to x divided by v, and you want to overload this, what you need to overload is dot operator, dot operator, and then you put the v inside, and you put the v inside, and this is the operator that you need to overload to uh, overload division. So to do that, I'm gonna do the exact same thing. So we're gonna come to the validated int, and I'm gonna say over here in the header file, and I'm gonna say over here I want a validated int to be created, to be returned using the operator plus receiving another validated int. So I'm going to write over here validated int reference, and let's call it over here other. And doing something like this, I am creating a binary operator between the two. Now, because side effect affects the owner and not the right one, I have to make this one a constant to guarantee that it's not going to change. So essentially, the binary operator that I'm going to create over here will have a validated int at right. So I'm going to ask it to create it for me. So as you see over here, the definition is created. Why is it not making it a call? Oh, that's perfectly good. So the definition is created, but I made a mistake too, because in here the operator plus is supposed to have not side effect from any of them, which means not only that, it means it should not change the owner. As a result, I have to add a const over here too, and a const over here to make it compatible. Now, if I look at it now, the problem is gone, and I can compile it. I can actually compile my code, rebuild, and you will see that it compiles. So it means we are good. Okay, so now that it's good, I can actually come back over here, invalidated int, and actually implement it. And I can simply say over here something like, we have, let me just remember what we had over here. We have an operator plus equal over here that is do the plus equal for us. So, and we have a set value. Let's do the set value. That's easier. So I'm going to use the set value. In here, I'm going to say, first I have to create a temporary validated int to return it, because this function, this operator overload, does not change anything in the owner. And what is that? The thing that is supposed to get returned is supposed to be validated it with sum of both. So what I will do over here, I'm going to create something like um, validated int, and I'm going to create sum. And what I can do over here is simply put m value of the current one plus m others m value, and what we want to have the maximum value to be. I can set it up to whatever I want, depending on what the business logic is. So I will actually, let me turn this off, and I will actually set this one, let's say, to the minimum value of the left class, left operand, and maximum value of the right operand. And that's that. What am I missing over here? So the constructor accepts. Oh, we have a title parameter too. So in here will be set to the title that we have, m title. So now the validated that I have over here, validated value that I have over here, will be essentially returning sum. So now the plus is overloaded for my validated integer, and it can actually work. So this is what we've done last time too. We taught actually how a binary operator can be overloaded for our class, and that when you have a binary operator, the left operand is always the owner of the operation, and that's how we went through. Everybody's okay with this? Give me a thumb up if you are. Raise your hand if you're not and you want to have a question. I'm going to remove these things from the last time. We don't need it. So now in here, I could have something like x is something, and I'm going to have over here between 0, so it's going to be the value for it will be I'm going to put over here 20, and I'm going to say minimum is 0 and maximum value is 100, something like that. So when we create this, as it runs through it, we will see that it gets executed, and as you see, the left one says number, and the right the left one says something, and right one is a number. So it's gonna go to the left operand, that is x. Therefore, as you see, the title that is going to be set will be the title of this left one. Value is the sum of the two values, and minimum maximum value is the left one, that is x. So sum is created with that. So it becomes something between 0 and 100, and the sum is now the sum of both. And now it comes out, and we could have displayed it, but I don't want to do it. So we just explain how it's done. And we have done it for operations that have a side effect and change the left value. which is, for example, writing y is equal to x plus equal v, something like that. Okay. Now, when we do this, if I take a look at the operation that I have, you will see that uh, we do not have a plus equal implemented for receiving a validated int at write. It's receiving just a single integer. So how did it work? If something like this happens, remember that C++ tries to always resolve the problem. So it says, I have an X, I have a plus equal. Now let's see what do I have at write. And looking at the signature of all the available uh, functions, it comes to this one and takes a look at it, and it says, okay, at left side I have a validated int, that's a match. The operator is plus equal, that's a match. The arguments that is supposed to come is an integer, but this is not an integer. So it says, can I convert this to an integer? Can I do int? Is this tool available? And it looks at it, it says yes, you see? So the integer is actually casting, is overloaded, therefore that's gonna work, and it doesn't need overloading. So sometimes when you do specific type of overloading, it causes implementation of another. If you are satisfied with that, you can just let it be. If not, you can actually do the overload and say, hey, I don't want it to be casted. When it's like that, I want to take over it, and I want it to be done my way. If that's the case, then you can actually implement the other one. So if I do implement the plus equal over here, it's going to be looking like this. But the difference is that because it is returning X, which means I can actually return a reference because X is present over here. Because X is present over here, I can return its reference. I don't need to create a temporary one. And the left one is not supposed to change, so I will remove this const, and I'm going to make it a plus equal. So now this plus equal of mine is essentially what's going to handle this one. If I did not write it, then it will try to cast it, and as you see, casting had happened and it can work. And overloading this again is exactly the same thing like the other one. It doesn't make any difference, so I can just copy this over here. Or actually, I'm going to do the set value. It's easier to do set value. So in here, I'm going to go set value of this object to m value plus other dot value, and done. And then return this, return me out, and it is done, and plus equal is good. So should I bring up your names, or are we okay? You're gonna be talkative. I want you guys to actually take part in it. So are we all okay? Give me a thumb up if you're okay with the review that we have done from the last time. Ian is okay. No one else is okay? Good. Judy's okay too. Thank you. All right. Oh, and I'm being getting a round of applause by Ethan. Thank you very much. All right. Good. So we have it. Good. Thank you. So we're good. With unary operators, we said because they are not two different things, you can always assume that whatever the unary operator is, that is going to be the owner. So if I write something like x minus minus or minus minus x, this is a unary operator, and what I need to actually implement over here will be a y dot operator minus minus. And obviously, depending on what I want to get at left, if it's y, then it's going to be, sorry, x. Then I have to say y is equal to something. Or if I want to overload the postfix one, x minus minus, then what I need to overload would be The exact same thing, but the difference is that to indicate that this is the postfix one, I have to put an int. And as I mentioned, int only is used for minus, minus, and plus, plus. Nothing else can be postfix. Remember, the operator must exist for you to overload it. I cannot overload, uh, say, something like this. I cannot say I want a y to be equal to x plus. You can't do that. A plus is only can only be a unary operator that is prefix. Because there is no postfix plus, you cannot overload it. You remember that the operator must exist for you to overload it. And that was the unary operators we created. Um, just to show you that other unary operators can be overloaded too. What I will do over here, I think we have a display function here somewhere. Do we have a display function? Yes, we do have a display function over here, and as you see, it's a const display constant. It's not it returns and it returns the validated int. Um, but you will see that from now on, I'm going to actually fix this. From now on, at any moment of time when you want to display something, or make it printed uh, on the console. So in here, I'm going to say IO input output. What you need to do, I'm going to change the signature of this one, and I'll show you how it's supposed to be done. You have to always return an OStream reference and receive an OStream reference, OSTR. And by default, set it to standard cout. Okay, so and to make sure that the header file can work, I am going to include IOStream, and because it's a header file, you cannot use using namespace. We talked about that before, so I'm going to actually change this to std OStream and std str. So this is the signature that you should create at all times. If you want it to be for reading, then you have to say std iostream reference read, whatever function you are writing, read, get, scan, whatever, and std iostream reference istr equals to std cin, which means if the if the um, the argument is not provided, automatically it receives from console input. You will see what it benefits from when we go through it. So I'm going to bring the display over here at the bottom and fix it. So I'll do a display. Now obviously in here I'm going to return an OStream reference, and I'm going to receive an iStream reference istr, and all you need to do over here, why is it giving me an error? It shouldn't. OStream reference, let me look at them both at the same time to see what is it talking about. Oh, I'm writing iStream. It's OStream, sorry. OStream OSTR. Okay. And what you need to do instead of, let me see if we have IOStream included and using namespace std. Good. Let's go back here. So what I should do over here is simply saying I want to have OSTR used for printing it out. And I'm going to remove the std over there. So it works exactly the same way, but instead of cout, you use the OSTR, and it's going to display it. And at the end, you're going to return that OSTR back, and you are done with your display. So the display is created over here. I don't know why it's still doing that. Let me see if Yeah, there you go. If I want to do read, so I can simply do the exact same thing for it with iStream and ISTR over here created for read. Okay, so to read actually a validated integer, I need to get few things back to back. So I will say um, name. So I'm going to write over here cout name. And in here, I'm going to say istr.getLine because I want it, if it has space in it, to accept it. So getLine will use it. And we have a total of 21. So in here, I'm going to say put to mtitle 21 characters. And that's going to receive the uh, title. Then I'm going to say cout value. Then I'm gonna say istr instead of cin, and I'm gonna read mvalue. Then I'm gonna have cout max acceptable value, and I'm gonna have istr max value, and receive the minimum value. Minimum acceptable value. I'm going to get the actually it's better to get the minimum value first. So I'll put the minimum value over here. And then at the end, I'm going to return ISTR. So as you see, implementation of reading can be long. There's no problem as it is for writing. So running this program, it is going to go through receiving the values. So in here, X, instead of using it like that, I'm going to say X dot read, and that's it. And because I'm not writing anything over there, it will accept it from cin, and then in here at the afterwards I'm going to say x.display, and that's going to display it. So when I run the program, let's go step by step. It comes through read. So I'm gonna bring it to left and have the outcome at right. And this is February 9th. So as we see over here, it comes through. It creates them both. Then read goes to cin over here. ISTR becomes cin, and shows that to get the name, I'm going to click over here. I'm going to go through it, and I'm going to say sample number and hit enter. So as you see now, title is sample number, and it accepts spaces too because I'm using getLine. And now it wants to ask for the value. I'm going to go through the whole thing all at once. I'm not going to do step by step. So I'm going to step out of the function. If you go to debug, I can say step out. It means execute the whole thing and get out, and that's shift 11. So I'll go shift 11 and it runs the whole thing. So it's in here. I'm going to put 10. Minimum accepted value of 5, maximum accepted value of 50, and I hit enter, and now X has those values set. Okay, now the display displays those values, so it's going to say title, sample number, value is 10, range is between 5 to 50, so it reads and writes it. So that's a read and write. Now that I have the read and write, let me show you that we can actually have unary operators with no what should we call it, another one rather than plus plus, because unary operators, I just showed plus plus and minus minus. Let's say I want the tilde operator to display something for me, to display the object. So what I will do over here, I'm going to say I'm gonna say OStream reference operator tilde, and in here I'm gonna say OStream. Oh, we don't put anything over there, and that's it. So, and that's a const, it doesn't return anything. Now what we do over here is to overload the unary operator, and as you see, the unary operator over here works exactly like a regular function. And in here I'm going to say return display. So now in my program, instead of displaying, I can actually say, actually I'm going to do two displays. Let me remove these two. I can do like this, X, and that means display the X. So if I run the program again, testing 10, 5, and 50. As you see, it's printed twice, and unary operators can be overloaded too. So writing something like this, essentially I am overloading operator that belongs to X. And you can actually call it like that too. So in here I can actually say X operator tilde. It works the exact same way. So I can call it using the operator function format or operator format. If I run this program again, you'll see it's going to get printed twice. So test 10, 0, and 100. As you see, it's printing it the same way. So yeah, all the operators can be called in both ways. Are we good down to this point? All right, now I want to do something over here that we'll see that it requires a specific type of, so in here I'm going to put it review, so a review.cpp. Let's go back in here. What I will do over here is to overload things that are impossible, which means what if I want to have something like integer val, and I want to say val is equal to 5 plus, say, v. If I want to do something like this, it will work, as you see over here. Why? Because it tries to, it says I have integer, and plus, everything's good. Now I have v at right side. How am I supposed to handle this? It says, okay, can I convert it v to an integer? The answer is yes, and because you can do it, then it's gonna actually cast this to an integer and work. But if I did not have the casting, then what would have happened? So I'm going to comment the casting. So one way to fix this, and now you will see that it's not going to work anymore. One way to fix this is to actually make this convertible to an integer. That's one way. Another way is to actually make this operator work. Now, the dilemma over here is that, the paradox over here is that we mentioned that by default, the left operand is the owner of the operator. That cannot be because 5 is a primitive value. It cannot have any members. How do we fix that? Here we can actually overload a helper operator. A helper operator says you can actually overload any operator as a standalone function that doesn't belong to the class. But this, I repeat, should always be done as the last resort, as if you cannot uh, uh, you are not supposed to do it for when you can make this a member. Always member first. If not, then you can always do it like this. Val is equal to operator plus. As you see, there is no owner over here. And because there is no owner over here, this becomes the first argument becomes the left operand, and the right argument becomes the right operand. And now, if you implement this helper operator, then everything can work. So how do we do it? Let's actually bring it over here. So what I want to do is create a helper operator overload. So first of all, it's got to be outside of the class. It doesn't belong to the class. So what it returns obviously is an integer operator plus. At left side, it receives an integer value, integer left. And at right side, it's receiving a validated int. Now the problem over here is that the validated int that we have over here, is at right side, but it's not supposed to have any side effects. So we must enforce the constantness over here. Make sure this is constant, and this one's going to be the right one. Now, if I implement this, then as you see, that's going to be gone. You see the message is gone. So let's implement it. So I'm going to come at the bottom, specifically mention that I'm using helpers. Now in here, I'm going to say int. I'm going to bring the exact same thing. Okay, so what I need to do over here is to take the value inside right out. So somehow I need to gain access to the value. But as you see, oh, we have a get value. Fantastic. Okay, so get value. I'm going to take these things out. Okay, so get value is getting the value, so I'm good. So I'm going to come over here. I'm going to say return left plus right dot get value, and I'm done. And because if I did not have if I did not have const in here, you would see that this wouldn't work. It's going to say this is not modifiable. So you got to be careful. That's the reason that I always say you have to always make sure that you enforce the constantness when the logic dictates it. So in here I'm going to put the const to go back to what I had before. So now in this operator overload, as you see, val is going to be so I'm going to say over here val is going to be okay. So now when I run this, let's see what happens. So it comes over here, validate val and all the stuff. So it comes right to this function, and in this function it's gonna get the value at right. So it gets the value of that one, that is 20, then plus left is 5, it becomes 25, returns 25 into val, and val becomes 25, and we're done. So these are helpers, and they come handy when you cannot make an operator a member. In the book, it talks about friends and friendship. Okay, so let me create you another function and implement it in another way, and I'll tell you you're not supposed to do this. Okay, which is, let's say I do a minus. Let's say I want to have this done too. I want to be able to say val is say 30 minus v. I want to do this. So if I want to implement this, obviously I am supposed to write this value. Do this. Minus. Okay? So if I do something like this, then what's going to happen? Yeah, well, we're going to say it's not something uh, um, difficult. If I wanted to, I could simply uh, use the same thing and make it a minus and make left minus right value. And that will work. Everybody's okay with this? Are we okay with this? People? Should I bring the names up? I think I should bring the names up. Yeah, Ethan say so. I'm going to bring the names up if you don't answer my questions, okay? Then there's got to be a attendance happening today. Okay, what I wanted to say, what if this class didn't have get value? Okay? What if didn't have get value? First of all, if the class is yours and it doesn't have get value, then implement the get value and be over with it. Okay, so that's your first thing. But if for some reason you do not want to create the get value and you want to actually access write, so you want to say over here write dot m value. This will get prevented by the compiler saying, hey, this is it's inaccessible. It's a private thing. You cannot access it. What many programmers do, and is a huge mistake, is to bring this function's prototype inside and make it a friend. When you do something like this, then you're essentially saying, I don't know why it's giving me an error over here. No, it doesn't know that it's a friend. That's a mistake. But anyways, now when you come over here, you're not going to get any error anymore. Because now this outsider has access to the entire class. It can manipulate everything. But remember, this is not a member of the function, and this is a wrong thing to do. Never, ever create a friend operator or friend helper class if you can create some kind of an accessor to only give access to what it needs and doesn't open everything. So this will give access to the entire class, and it is wrong. Never use friends, and always create a query to give the outsider what it needs, and only that and nothing else. So what is the difference between these two? In here, I only have access to get value. But in here, if I'm cuckoo enough, I can say str copy into title some garbage. I can do that. Why? Because I have access to, write title. Or do whatever that I want. So it's a bad thing to do. You're not supposed to have access. Or I can print the value out or extract the value. I can say over here min value, which is wrong. It's not supposed to happen. It is only supposed to get the entire inside value. So by creating a query, you're only giving access to what the operator needs and nothing else. So I'm going to say this is wrong and it's not supposed to be done. And you should not do it unless you are asked to. I may ask you to write a friend function for me in a test to see that you know the syntax or not, but you're not supposed to use it. Be careful. Do we understand this? Do
Yes.
we? All right. Thank you. And now, what if I want to do this? What if I want to print V exactly like I do any other variable? What if I want to read V exactly like I read anything? The answer is it's very easy. All I need to do is to overload what is needed. So in here, when I'm doing cin, the way I taught you, because cin over here is O stream, I cannot go hack the compiler and add methods to it. So I have to write a helper method, helper function. So for a helper function, what do? At left side, I'm supposed to receive a cin. First of all, the operator is extraction. So I go operator and I do like that. As left operand, I'm receiving iStream reference left. At right hand, I'm getting validated int reference right. And I do not need to make this thing a constant because I'm supposed to modify it using cin. Now, because I want to be able to do this too, if I want to, the outcome of this must be another cin. Because of that, I need to return the iStream to guarantee cascading can happen. Same thing over here. Cout will print the validated int, and as a result, it's going to return. As a result, it's going to return cout. And then we're going to have this, and we're going to have v, and then is here. So what I need to do, I need to resolve cout insertion operator and validated int, and I need to return again a cout so the rest can get printed. So what I need to do is to overload, obviously, operator insertion operator. It returns OStream reference, and it receives an OStream reference left and a constant validated int right. Why constant? Because I am printing V. I don't want to change it. So let's take this and bring it in the header file and start implementing it. So I am printing. So two things I need to do. OStream operator and then print that, and do the same thing with iStream to read it. So this is going to be iStream, and this one, oh, and iStream, and obviously not constant. And excuse me, my apologies. Okay, so yeah, so now, and again, because I'm in the header file, I need to have the std added over here. And now I can implement it. And the implementation of this one, because you created the display and read properly, is just a second. So remember this. This, I'm going to say IO helpers. This IO helpers should, you should be able to do it with your eyes closed. Okay? Very simple. And the signature is always identical. O stream, operator insertion, O stream left, and object right, whatever you have, whatever class that you have, that is a constant. Or I stream operation extraction, I stream left reference, and the class reference right, that is not constant because you want to change it. Now, because these two functions are doing exactly that, I can in a second implement it. So I can simply say, for displaying, all I need to do is to say return right dot display and pass the left to it. Done. So essentially it passes the left to display, passes the calls the display of right, passing the left to it. So the O stream flows through the object and goes out. And it's the exact same thing for iStream. When you're implementing it, it does the exact same thing, which is essentially return right dot read, and it receives left over there. And we are done. It's as simple as that. So you will be asked over and over through entire semester, okay, to implement something and then make it insertable and extractable into OStream and iStream. The syntax is identical in all of them. I can even ask you a question like this. I can ask you a question like this. I can say, if a class name is, what do I say? A car. Okay? Make it insertable and extractable from to and from OStream and iStream. Immediately your response would be, it's like 3 seconds. Immediately you're going to say OStream reference operator. At left side I have OStream reference OSTR. At right side I have const car reference right. Done. And then you implement it. And for the other one is iStream reference operator extraction, iStream reference ISTR. At right side I have a car reference right, that is not a constant. As simple as that. You implement these two and you're done. And if you are a good programmer, your car already has a display that passes OStream through it. So again, all display functions and read functions that are supposed to display and read to OStream and iStream, they all must be created the exact same way. Are we okay with this? Okay. Any question, anyone? By the way, remember the day after tomorrow you have the quiz that you missed, and next week you have your midterm. Okay, remember that. Yes, Ethan, go ahead.
Yes, Professor. In case because now we have display and read function,
Mhm.
but if in, for example, in midterm or in the quiz you don't, we are not given display and read function. What should we do?
Write it.
Oh, we should write.
Yes. Never make it
Yeah.
a friend. I know where you're going. You would say, can I make it a friend and print it out? The answer is no. In my class, if I give you this and I'll tell you make it insertable, if I give you the question, I give you the car class, and I ask you to make it insertable and extractable from IOStream, and I do not give you a read and write function, you must implement it and call those in it. You never make it a friend. Remember that. Thank you for the question. You should never make it a
Yeah.
friend. Just implement the query and the accessor and you're done. So if you have, this is a golden rule. If you have access to the class and you can add to the implementation of a class, create the query or accessor you need for your helper functions to be used in those functions. So they can only access what they need and nothing more. But if you make it a friend, it's an easy way out, but it creates a loophole, a backdoor that later on is going to be causing lots and lots and lots of bug. So please do not do it. Be good? Are we okay, everyone? All right. All right, so let's see what else we need to cover. Uh, ba, 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 ba. Helper function and input output operators. So it says helper function. So helper function essentially, I don't know. This is when I tell you you can write a helper operator, you can write a helper function too. I could I could have something like this. I don't know. Uh, Validated int multiply and const validated int helper a and const validated int reference b. I can write something like this. Okay, there's no problem with it. Essentially, any function that is not a member of a class, it's any standalone function that is not a member of a class and receives the class to do something with it, we call it a helper function. Okay, a helper function is a function that is designed to work with a class but it's not its member. Okay, you can, and operator overloads are a perfect example for it. So uh, oh, sorry. If the following is to be implemented, if the following is to be implemented, it will be called a helper function because it is a function that is not a member, but it is designed to work with specific classes. Okay, so that's that. It's as simple as that. Um, so when we say helper functions, it's essentially the same. It doesn't make any difference. So what does it say over here? Free helpers, yada yada yada. Yeah, helper operator. Yeah, helper operator for comparison is very normal. Like if you want to compare two validated instances to see if they have the same value, you overload the boolean, but never ever as a helper. Like this is an awful example for a helper because it is left hand and a right hand is supposed to do it. You use it as a member, so you never make a helper function to do equality check. If I want to see uh, a validated int is equal to another, I'll go boolean operator equality check, and I'm going to say over here constant validated int reference other. I'll do this, and obviously it's a const too, and that's it. I just create this. Oh, not plus plus. Sorry, equal equal. Okay, and I can just create it, and I can simply say over here return M value being equal to other dot get value. Done. So as you see, why is it giving me an error? Expression must be, oh, equal, two equal, sorry, yeah. So yeah, so now it returns if the two things are equal. Now it is working. So there is absolutely no need to make an operator helper if the left side is a class of yours that you can modify. Okay? Or this, for example, awful thing to do. Left side is a student. Why do I do an operator plus and receive a float at right? If float was at left, this I understand. This is perfectly good. This, I understand. This must be a helper because left side is a float. But the right side is a float. That has to be a member. This is wrong. And that's the friendship that he's talking about. I wouldn't even teach it. It's a bad thing to do. Go, don't do. And friendship with classes, we'll talk about it later. But this says optional. It's not optional in my class. If you want to actually read this, go through it and read it. That's very fine. But later I'll explain it when the time comes what friendly classes are. And that is that. Input and output operators. Oh, it's actually mentioning file IO2. Good. So now that we have learned this, when does the class end? The class ends at 1:25. I have around 15 minutes to go through this. It's very simple, and it will be done. Okay. Now, just a second. All right. Okay, um, so in here C helper io.cpp. Okay. Today you're gonna see how inheritance works in C++. So we have learned how to write stuff on a screen. As easy as that. Um, I have a question. Who should I ask? Any volunteer want to answer my question? Raise your hand. Lance, okay. So activate your microphone and let's. I'm gonna ask you a question through this back and forth, and we're gonna learn a few things. Okay, you there, Lance?
Yeah.
Okay, fantastic. So, um, if you learn how to drive a car, okay, and the car that you learned how to drive on was a Toyota,
Okay.
and then I give you a BMW to drive. Can you drive it?
Yes, I can.
Why?
Uh, it's they both
They're both
how
cars.
they work is similar.
They
How they work is
exactly. They are
similar.
both cars. Or if I give you a gasoline car, ICE car, internal combustion engine, not those crazy people down the south side of the border, an internal combustion engine car, a car that works with the gas, and I'm going to tell you to drive this, you can't. But then I give you an electric car, you can still drive it. So, and thank you, Lance, for that. Why it happens? It's because they are both cars. They both have same parents. They are all inherited from same object. If you learn how to deal with the parent, you can deal with the children because they work the exact same way. We're going to learn later on after the break how to implement it, but we're going to learn how to use it now. When we are dealing with, did I close that? I think I closed my browser. Yeah, I closed my browser. So actually, let me write it over here. So when we are dealing when you're doing input output, this is how actually happens. At the top, you have a mother class. That mother class has all the basic input output system that you need. It's called iOS. Okay. Then iOS has two children. Okay. It's inherited into two. Sorry. It's inherited into two classes. That's one class, that's another class. One is iStream and the other one is OStream. So these two are inherited from iOS. Now, they want to be able to write in a file. What they did, they didn't want to reinvent the wheel from scratch, so they said, okay, this is what we're going to do. We're going to create a couple of more classes that are essentially children of iStream and OStream. And they called the first one, so they inherited iStream into ifstream, which essentially it does input, but instead of keyboard, it does it from a file. And then they created an OF stream that does output instead of a screen in a file. But the basics are exactly the same. Then they said, wait a minute, you are reading from keyboard and writing on the monitor. You never read from monitor and write on keyboard. That's crazy. That's why we have two different classes. But when you are dealing with the file, you may want to read and write from the same file. If that is the case, then C++ has an amazing feature. Oops. C++ has an amazing feature called multiple inheritance that you're not going to learn now. It's going to go to next semester. But again, we never learn how to use it. We're going to learn how to implement it next semester. And they inherited these two into one class and they call it fstream. So fstream is a child of ifstream and ofstream, and its grandparents are istream and ostream, which essentially means fstream knows exactly how istream works. So assume that iOS is a car and I have just the left one is a pickup truck, another pickup truck, and the right side is a sedan and another sedan, and down here I have one of those pickup trucks that is a sedan too, and it's a five-seater. It's something like that. So the inheritance happens like this, and all these things are going like that. So just remember this, as I told you. Now, in here, I'm going to write a piece of code. So in here, I'm going to create that validated int that you have. Or let's do another thing. I'm going to write over here integer val, okay? And I'm going to say cin val. And let's do something else. I'm going to say I'm going to have cin value. integer value. I'm going to read the value, C in val, and I'm going to say C out. So in here, I'm going to say C out, enter an integer. And in here, I'm going to say the number you entered is va. Okay? We know how it works. If I run this program, it simply reads something and enter an integer. I'm going to put over here 100. It's going to say the number you entered is 100, right? But let's say I want to get an integer and I want these two information to actually be in a file. And so to be saved in a file called report. What I can do over here is to say OF stream, and OF stream is, by the way, the name of the header file that all these things are in is F stream. So include F stream. Okay, so essentially I'm going to say OF stream. Now, any other volunteer who wants to answer? Anyone? Seriously? Should I bring up the thing? No? Let me see if I can find somebody. I don't want to pick anybody. Can anybody know what is going to be volunteered? I'm going to bring the random name up. Nope. Okay. So, who should answer? Let me see. Judy, you're here?
Yes, I'm here.
Okay, you're the victim. Okay.
Okay.
I have a question. Okay, first of all, you know what constructors are. Constructors are to build things, correct?
Right.
Now, I have a question. If you were to write a class that represented a file, what would you pass to its constructor? Represented the file on a hard drive. What would you pass to the constructor?
Create an empty file.
Yeah, but a file, what represents a file on a hard drive? Like if you want to create a file on a hard drive, what do you need first?
The directory?
Yes, but inside directory you want to create the file. It's a very simple question. You need a what for a file?
Name.
Thank you. We need a name for a file. That's all I wanted to know. So because now you can turn your microphone off. So because a file is essentially something on a hard drive, they said we need to pass, because it's not like cout. You don't create cout. Cout is already created for you in OF stream. Why? Because cout is your monitor. You don't have two of them. It's one. You don't need two of them, but files can be 50 of them. So they say you have to create the file. It's not going to be created for you. And when you do it, you need to give it a name, whatever name you have. Okay? Now take a look. OF stream is a child of O stream. O stream is cout. All I need to do is to copy this, replace the cout with file. See, I didn't do anything. I did exactly what I did with cout. I only put a file instead. When I run it, you will see that it's not going to show you anything. It's just going to say, oh, sorry. It's going to say enter an integer. And then all you need to do over here is say I'm going to enter 100. Oh, 100. And I hit enter and program ends. So the messages you printed, they are not here. Where are they? You look at it. there is a report.txt, and inside report.txt there are things that you have. So the beautiful thing about object orientation is that you do not to learn new things for similar stuff. They all work just fine. For example, if I wanted to, so let's write in here file. So if I wanted that value to be printed in 10 spaces and have asterisk at left done, I can do it exactly as I have done with cout. So I can just do it like this, as if I'm formatting it with cout. By the way, remember, if you have watched the video, and hopefully, and I asked you to do it, you know that you're not allowed to use manipulators, only member functions to do formatting. So like cout, you can say file dot width, because it's a child of that one, it knows. I'm going to say 10. Then in here I'm going to say file dot fill. I'm going to make it 0. So I want to fill the left, not 0. Let's put what do I put? Carrots. Okay, like that. And I'm going to say file dot set f iOS right, and obviously we say file dot set f unset f iOS right, and we're done. So now if I run this program, and let's call this report 2, report 1, whatever, let's make it 2, report 2.txt. So now if I run this program and I put over here 100, when I open report 2, you will see that report 2 is formatted exactly as how you do it on cout. So again, I don't need to teach you anything. All I needed to tell you is that you just instantiate and you do read and write. Let's try another thing. So I'm going to write over here abcde dash file IO. Okay. Now I'm going to do this. And let's actually open this report.txt and put it side by side. Okay, so I can, instead of if stream, OF stream, I'm going to say IF stream. So it's going to open the file report.txt for reading. Now I'm going to say over here, say character str81. I'm going to put 81 characters in there, and I'm going to put an integer value in here. Now I can start reading whatever I want. How do I do it? If I say over here file, and I put str and I go cout, Timojin, can you tell me what is
Yes.
the output of this program? Think about as if somebody is typing this entire thing on the keyboard, and this is cin. Then what will go in str?
OOP244 NBB February 9th.
Kind of right, but no. It's going to read just OOP244 because the delimiter is, cout str, because the delimiter is actually space for extraction operator, remember? So it's going to stop at OOP244. If I want to read to the end, I know how to do it. I can simply say file dot get line, Actually, I want to read up to dash. So I'm going to say get line. And in here, I'm going to say up to, read it to str, up to 81 characters, and stop at dash. So what's going to happen now? When it reads it, it reads OOP244 NBB space. You see that?
Yeah.
So it reads it down to those. Thank you. You can turn off your microphone. So it
Thank you.
works the exact same way. Now I can do another file and I can go str again, and I know that February is going to be red. So I'm going to go see out str and L. So as you see now, it's going to say OOP244 NBB, and that dash is eaten because that's what getLine does. GetLine stops, reads, and throws it away. So that's that one. Okay. And if I didn't want it to eat that uh, dash, I could say just get. If instead of getLine you said get, it doesn't eat the dash. So now if I run this program, this time it's going to say and reads the dash. And now I can actually do something like say dot get dot. So in here I'm going to make it a get line. Okay, so it's going to stop and print February. Okay, and then I'm going to say, I'm just parsing through the file to show you that you can actually program exactly what you want to read, whatever you want. So in here I can say something like, now I can say file into val because I know February is red, and see out val. I don't know why I put an L over there. My apologies. And then I'm going to say file dot get into str up to 81 characters and stop at character 0, at character 1. So I'm going to read it right up to 100. Then I'm going to say see out str again, and now I can say see in into val, and it's going to read 100 because get does not extract 1. Does not extract 1. This does extract dash. Okay, so in here I'm going to say see out val. So when I run this, you'll see I'm going to read everything step by step and go through it and display it right to the end. And oh, what did I do wrong? So let's see, what did I do? So I read up to dash, good, and printed it. Then I read another one that's February. I read it. Then I read in val. Obviously, that's 0 is skipped. It's going to be 9. And now this one's going to read to that one. And why it didn't read the 100? Let me see what's going on. So I'm going to go through it. Come over here. So val is 9, and it reads the string. String has a new line at the beginning because I didn't read the new line. So it reads the new line in the file, which is fine. Then it displays that one, and it has right up to is, yes, and val now it's supposed to read 100. Oh, I put C in. I should have put file. My apologies. My apologies. Okay, that's bad. Okay, there we go. So this is what is printed. I'll go through it step by step, and as simple as that. Okay, so file are read like this, so you can program it any way you want. The good thing is that you don't have that stupid user that keeps making mistakes. When you're reading from files, you know exactly what the format of the file is. You tailor exactly how you want to read something from a file, and you just do it. It's as simple and straightforward as like that. So reading, writing in a file, reading from a file, exact same thing with absolutely no difference. Are we okay with this? People, are we okay? All right. Yes, Roman, go ahead. Did you raise your hand or you wanted to say okay by mistake you put the hand up?
Yeah, it was an accident. Sorry.
That's okay, that's okay. Let me just find something over here from the file to give you a quick demo. Um, OOP244 we are in. And I have, okay. I'm gonna copy this. There we go. Add existing item. Oh, okay. This student, you see student, it has student name, comma, student number, comma, a mark, or series of marks and student numbers I'm reading. If I want to read this, how do I do it? So let me just go to a new one. So I'm going to say over here, ef dash file io.cpp. Okay. Oh, so it's a student and a GPA. So what I will do over here is this. I'm going to create this. I'm going to create a class. I'm going to say class student. It has character name. I'm going to put 81. It has size T student number. Actually, let's put M. And I'm going to have a float for a GPA. So this is I have as a student, public. Okay, I'm going to initialize everything so they're all empty when we start. Okay, then in here I'm going to create iStream reference, iStream reference read, iStream reference read CSV, comma separated value, iStream reference ISTR, and I'm going to say equals to stdcin. I'm going to actually write it right over here. So I'm going to say return ISTR. So what do I need to do? I have a student and I want to read the student. What do I do? First, I'm going to read the student up to comma. So I'm going to say ISTR get line into mname up to 81 characters and stop at a comma, and I'm done. Then I'm going to say read ISTR into m student number. So that's going to automatically read up to comma and stop. So I need to get rid of that comma. So I'm going to say istr.ignore, ignore one character, and I'm going to say istr dot istr into mgpa. GPA, I'm going to get the GPA, and then after that I don't know how many things I have to pass to get to space, so I'm going to say istr ignore, I don't know, 1000 characters and backslash n. So it means ignore up to backslash n and stop, and I return it. Done. So I'm reading the thing with this, and I want to write it. I'm going to go ostream reference write, and in here ostr ostream reference ostr equals stdc out, and I'm going to say cout name. Name is mname, cout, and then mname, and let's print everything and be done with it. Oh, not cout, ostr. That's a very common mistake. You see how many times I made that mistake? You're going to make that mistake too. And L, and then I'm going to say over here student number, student number, and L, or we can actually put it in one line. That's easier. Student number, and at the end I'm going to say GPA, and GPA, and display the GPA. And for GPA, I need to format it, so I'm going to stop right over here, and I'm going to say OSTR dot set FIOS fixed, because I don't want it to jump around, and I'm going to say OSTR dot set precision precision 1. Now I'm going to say OSTR MGPA GPA, and I'm not going to go to new line because I don't know if they want to go to new line or not. There you go. I have my student received, and if I wanted to, I want to print this out on a screen using C in and C out. I told you it's exactly the same for all of them. So you simply go OStream reference operator insertion, OStream reference stream reference right, and then you go const. Oh, by the way, this is this right. It's supposed to be a const. You go const student reference, sorry, right, and this is left. So I implement this, which is essentially return right dot right student reference right dot right, and I'm going to pass left to it. Okay. Why is it giving me that? Oh, because I didn't do this right. That's the one. There we go. Okay, and the other one is iStream reference operator extraction, and iStream left, and student reference right, and in here it's going to be return right dot read CSV, and I'm going to pass left to it, and done. Now in my program, what I can do is to open if the name is student.csv, and in here I'm going to say while file is okay, I'm going to say I'm going to create a student S. I'm going to say file S, and in here I'm going to say cout S, and I'm done. So what happens over here is that it receives everything from the file, hopefully with the proper format, and I hope that you notice this is not IF stream, it's iStream. See, my name is Fardat. You can call me Mr. Solimandik. So you can always use my parents' last name to call me. It's the same thing with objects. If iStream is father or mother of IF stream, you can always pass an IF stream to an iStream with no problem. You can always use its parent's name to call it. And that's the beauty of object orientation and inheritance. Now, if I run this, if what I've written is correct, it's gonna, oh, give me a build error. Thank you very much. After all the, oh, I forgot to return. Sorry, return OSTR. Yeah, so when I do this, and I should have gone to new line. Yeah, I forgot. So, and L, and as you see now, it's going to go through the file and print all the names. So, and as you see, there is last one over here that I'm printing that I was not supposed to. I don't know what's wrong in there. Oh, because I have one extra line in here. And so I have to only see out over here if the file is valid. I'm supposed to, because when it read, it failed, but I didn't detect it. Now it's going to be okay. Now the last one's not going to get printed. See, there we go. As easy as that. So that's what files are, and we are done. It's very simple, very straightforward, and it works exactly like CN, and there is absolutely no difference between the two. I hope this helps. Any question? Suggestion?
So far, there is none because I am still a bit confused and try to figure out everything in my mind.
Confused is fine. Confused is okay. But later on, you can book a meeting with me, and I'll take the confusion away. There's no problem.
Yeah, okay. I'm just like trying to link all of the information together right now
Yeah,
in my brain.
but to actually make it fit, I'm gonna push it right now. So yeah, I'm gonna close this and push everything right now into the repo. What you guys need to do?
Do you think
What?
you'll be do you think you'll be here on Wednesday or no?
Check my schedule, Ian. I never answer stuff like that. Book an appointment, and I'll answer.
No,
Book an
I'm saying, you said
early in the
you're a bit
morning.
sick. Do you think you can
Usually
get
I
sick?
am. Usually I am early in the morning. I come early in the morning.
Yeah, I'm just asking, do you think you can get better by Wednesday?
Sure, sure. That's fantastic. Okay, so in here is helpers, helpers, and files. Okay, commit and push. So please pull it and start fiddling with it. Create your own data record files, read from it, go through it, see what goes wrong and right. Practice, and believe me, it's going to go in a second. It's very easy. It's much easier than trying to validate an entry that a user enters. Okay? Have yourself a beautiful day, everyone, and I'll see you on Wednesday.
See you.
Bye, everyone.
Thank you, Professor. Bye.
Have a good one.
Thank you, Professor.
Thank you, Professor.
Thank you all for joining. Thank you.